Okay, welcome everyone. Let's take a look at question 2 in this notebook. So question 2 is asking us to write a loop that is going to compute the mean of each row of a matrix mat, M-A-T, and we're going to store the results to some vector that we're going to call row mean. And then let's compare the results of our loop with the results that we got previously when we used an apply command to do this same exact action. So let's first create this loop, and then we'll think about how we can create a function from this loop. And so what's going to be useful for us to know if we're going to set up a for loop is going to be how many times do we want to iterate through this process. And we're going to want to do this 5 times. That corresponds to the size of the matrix. And let me just print that matrix out here. So we created this matrix earlier. So if you have not already done so, you might want to go back and just run one of the earlier code cells where that is defined. So first, I'm going to calculate the number of rows of this matrix using the nrow function. So again, that's going to tell me 5. That's the number of rows. That's how many times I'm going to want to iterate and calculate a mean value. Then we're going to need to store these values someplace, and we're going to store them in a vector that we call row mean. So that's what I've got here. And this vector is going to be a numeric vector, and it's going to have size, which is equal to the number of rows of our matrix. So far, I'm going to calculate and store the number of rows of our matrix, and then we're going to create a vector that has that many elements where we're going to store each of these means. Now we're ready to go into the for loop. So we're going to begin this typically with for, and then in parentheses, we indicate some iterator. I'll use I, and some vector that we iterate for values of I. So we're going to do this 1, 2, 3, 4, 5 times. So we're going to go from 1 up to n row. So this is n underscore row, and that again is equal to the number 5, which is the number of rows in our matrix. And now we enter a set of curly braces where we can enter the code that we're going to loop through. And so what we want to do is that iterator I is just specifying the index of the matrix where we're going to be storing our output. So for each time, for each row, what we're going to do is we're going to calculate the mean of the entries in matrix in MAT that are in row I, but we're not going to specify anything about the columns because we want to go across all entries in that column. So this is corresponding to all of, it's going to create a vector of entries that were in row I. And then we're going to calculate the mean of those entries. And then we're going to store that result in this ith position of this vector row mean. Great. And then we can take a look at what we get out of that function. So I'm going to run this, and we can check that we got the same values that we got up here with this apply function. So recall that this apply function was going to calculate the mean of each row. That's what margin 1 specifies in matrix MAT. So you can see here why apply functions are nice. They're way more concise and they're way more readable than maybe a for loop, which requires more syntax and is a little bit more challenging to interpret. But hopefully we're getting really fluent with these loops, and we can read this just fine. But let me go ahead and create a function out of this loop that I'm going to call my row mean. And this is going to be a function of the data that we enter. So no matter what I enter in for X, it's going to calculate the mean of each row of X. So that is going to indicate a function. And then we're going to indent all of this code that I had from earlier. And then we close off our function. So what we're going to do is we are going to return this row mean vector out in the end. So here, if I run this code cell, nothing is going to happen. And I also want to change something in my code over here, which is I want to enter X in place, because here we're going to leave X as kind of the generic reference for our data. So otherwise, I've kept the code the same exact way. Each instance of MAT, I want to swap out with X. So we're going to calculate the number of rows of this object, store that in n row, and then we're going to go in, and for each row of X, we're going to calculate the mean of all of the entries in that row and return it. So now if I run this, we won't see any output because this created a function, and now I can use the function and apply that to MAT, and that gives us the output that is, again, consistent with the output that we got using the apply function earlier.